Okay, good morning, and on behalf of TIChE, I would like to thank the committee and the advisor, and more importantly, the contestant who spent I think yesterday and today morning with us. And I would like to invite Professor Dr. Phornpot Piansambun, who is the judging committee, and I would like to invite him for the opening speech and also the problem statement explanation. อาจารย์พรพจน์ would you please be the honor to give the opening speech?
Thank you, Ajahn Thirasut. Can you hear us? Can you hear
Yes.
me?
Yes.
Clear, right? Okay. Thank you very much for everyone who attend this session today. It is a holiday and you have to spend some time with us. All right. And I would like to, on behalf of Chemical Engineering Institute of the Thailand Institute of Chemical Engineering and Applied Chemistry, I would like to welcome you all to the second TIChE AVEVA Process Simulation Hackathon. This is the second time that we organize this kind of contestant, this kind of competition. Actually, I would like to also thank the Department of Chemical Engineering for King Mongkut Institute of Technology Lat Krabang for accept to be a host of this event this year. As you all know, process simulation become more and more important tool for the engineer these days. We use process simulation for doing process design, process operation, process optimization, process safety, and analysis. There are so many things that we use this kind of tool for everyday work of engineer, especially chemical engineer. And therefore, I think the teacher realized this and would like to stimulate the student who are studying right now to pay more attention on this skill, because this skill will be an important skill for the current job of chemical engineer and in the near future of chemical engineer as well. And this is kind of lucky for us also. Actually, I have to thank President of TIChE, Kun Surachet, for try to find a sponsor to make this event happening. And that's why this is the second year that we have the AVEVA accept to be sponsor for this kind of event. Therefore, this year,
กดแล้วเข้า
อินเทอร์เน็ตหรือเปล่า
เปิดแล้ว
รบกวนท่านที่เข้ามาปิดไมค์ด้วยนะครับ sorry.
Okay, so this year we start the competition in the same format as last year, also in form of hackathon. Actually, the contesting like this normally they take a little bit longer time, but due to the limitation for the academic year in Thailand, it's hardly to find a slot that we can put the event quite a long time and can fit every university. Therefore, we still decide that this year we are going to conduct it as a hackathon. But anyway, this time we make it a little bit longer than last time. Okay, last time student will have just only three days, I believe. But this year, student will have time about a week for working on the problem. And I hope that with this extending time will give more opportunity for students to participate in the competition. So about a week from now, I hope that students who are enrolled in this competition, we have the opportunity to employ their knowledge of chemical engineering together with the using skill of the computer and especially process simulator to solve a chemical industry problem. And also they will have a chance to express their skill in terms of teamwork, working with your classmates to solve the academic problem. And I hope that this week from now will be a fun time for them and enjoy time for you to try to attack a certain problem which you might be facing in the near future. And I hope you have a good time within this week. Of course, it's gonna be disturb your Songkran holiday anyway. But I think if you decide to attend this competition, you have decided you're gonna spend more valuable time here. Okay. And finally, I would like to thank, first of all, AVEVA for supporting the software, the staff member, and the prize for the winning contestant. Secondly, I would like to thank the Department of Chemical Engineering, King Mongkut Institute of Technology, Lat Krabang, for accept to be the host of the event. I would like to also thank the TIChE student chapter for helping organize this event. And lastly, but not least, I would like to thank Professor Tirasut for energetically and work not tirelessly, I will say, to arranging, coordinating, and executing the related tasks to make this event possible. Thank you very much, and I hope you enjoy the competition. And I would like to say I officially announced the beginning of the second TIChE AVEVA Process Simulation Hackathon 2025. Thank you very much.
Thank you, Atan Pornpot. And 36 years ago, when I was student, I don't have this opportunity. You have more opportunity than me. So I hope that you all use it very efficiently. Atan Pornpot, would you like to
Yes.
start about the problem explanation, please?
Sure. Just a minute. My file has been closed already. Okay. Have you seen the file?
Yes, I see your screen.
Okay. Right. Okay, this is the problem statement for this year for the student to work on. Last year we working on the gray methanol, and this year we will working on the gray ammonia production plant. As you might know, that ammonia is a very important chemical because they can say last 100 years ago when we know how to produce ammonia that has increased the productivity of the agricultural product. And that is one of the crucial chemical we can say because it changed the world in the sense that we don't have to worry about that we cannot get the agricultural product enough for the high growing rate of world population. Therefore, ammonia has been used for fertilizer, plastic, textile, pesticider, explosive or dye. However, recently, due to the carbon dioxide emission and carbon dioxide concentration in the atmosphere, people start to thinking about another energy carrier that could help reduce the CO2 in the atmosphere. And ammonia has been one of the chemicals they are thinking of, that probably in the near future, we might burn ammonia instead of burn carbon or hydrocarbon. And that's why this is one of the reasons that we are interested in asking you to produce ammonia, right? But to produce the green ammonia is still quite expensive because hydrogen comes from the electrolysis is very costly. Therefore, we still keep on produce hydrogen from hydrocarbon, but from light hydrocarbon, like natural gas. So for this problem, you got to produce hydrogen, which is one of the components of the ammonia from natural gas by the specification of the natural gas that the problem statement give you, all right? And another component of ammonia is nitrogen, as you know. Nitrogen is abundant in air, right? So we have abundant source. However, we got to separate nitrogen from the oxygen and the rest of the gas in the air, which is probably another major component will be water, things like that. But in this case, we ask you to separate nitrogen from air by distillation column. Okay, you use the cryogenic distillation for separating nitrogen from air. And after that, of course, hydrogen, you use natural gas, so you probably go to with water gas ship or whatever. It has a process, but in this case, we suggest you going with steam reforming and water gas ship reaction in order to produce hydrogen. And after you got the hydrogen, then some of the components you don't have to worry that much in terms of treating or separating the carbon dioxide. So we ask you to use the pressure swing absorption in order to split hydrogen from the rest of the gas that you obtain from the steam reforming and water gas ship reaction. And after you obtain the nitrogen and hydrogen, then you go to the ammonia synthesis. Okay. And the ammonia synthesis, the reaction of ammonia is very simple, as you know. Up here is the reaction of ammonia. But in this case, we provide you the kinetic reaction for the ammonia synthesis. As you might see here, we give you both forward reaction and backward reaction kinetics. Why do we have to give you this? Because we would like you to estimate the proper reactor size for the ammonia reactor. And that's why we provide you the kinetics. Okay. And these are the information about the ammonia reaction, which is, in this case, it's very simple. We just have one reaction for the ammonia, but the other one might be a little bit more complicated, but not that much complex. This is the steam reforming and the water gas ship, which will be for produce the hydrogen. These three reactions you can ask for. You can use the if reactor or equilibrium reactor in order to produce hydrogen as you wish. Okay, and you might have to find the proper operating condition so that you can obtain the highest hydrogen with the less natural gas you use. Okay. So this is just a block flow diagram, a simple block flow diagram for you to see that the major chemical reaction takes place in all this. Actually, I cannot say that because cryogenic separation is not chemical reaction, but the major equipment that involve will be at least these 5 units. But of course, you might need something more than that. Okay, but this is just give you some idea about the process that we are looking for. Okay, and up here we provide you some information, like we would like you to produce 500,000 metric ton per year of ammonia. Okay, and the purity has to be minimum 98% more. The annual plant operating hour is about 8,000 hours. Okay, so use 8,000 hours so that we can check when we talking about 500,000 metric ton, we can see based on 8,000 hours on the same basis. Okay, and natural gas specification, these are the composition of the natural gas that we provide you. these are the utility that you might need to use, and this is the condition of the utility that we provide for you: cooling water, steam supply, demineralized water, air, electricity, or methanol in case of refrigerant. Okay. And what else? Okay, this the reaction. And mainly we will refer to the SI unit, but some unit might be a little bit different. Like, for example, pressure, we might refer to bar. Okay. And in terms of a report that you supposed to submit at the end of the competition, so what you have to submit is two things. One is simulation file, and the other thing is final report, a written report, which contain the simulation validation report and with the schematic drawing and material balances. You can use a PFD that get the snapshot from AVEVA process simulation. Okay. Temperature, pressure, flow rate, and composition of each stream should be indicated in material balance. By the way, you got to use the AVEVA simulation. Okay. We looking for the result in AVEVA simulator. Okay. And the report should have some description about the process and your analysis or your propose. How do you solve your problem? What are the key message that the judge supposed to know or understand how to coming up with your result? Okay. And we also looking for the explanation about the thermodynamic equation or any fundamental theory that might be involved for your work. The report also has to include the required of natural gas ambient air flow. So we would like to know how much resource have you used for your problem, the requiring of steam flow rate, and the size of the reactor. Also, in terms of utility, we would like to know about the electricity consumption. And since we are going toward the net zero, so I think chemical engineer this day is supposed to be able to know the process that develop how much carbon footprint involved in that process. So we ask you to develop scope 2 of the CO2 footprint for your process as well. Okay. Anything that you think you need, but the problem is not give you can write it down in your report. So the judge understand how those constant or those result come up or anything that you think it is involved and need to know, but it does not mention in the problem statement, should put in your report. And your report not supposed to have any institution name or whatever. We will put the just only code that Ajahn Tirasut give it to you. So we don't want to know which team come from which university. Okay. So don't put anything that relate to your university, so that we will marking this report blind. Okay. Okay, I think that will be all for the problem statement. If there are any question for now, maybe you can ask. Okay.
Ajahn Pornput, the question can be in Thai or in English. Is that okay?
Yes, of course. I think.
คำ
But
ถาม
in
จะเป็น
English will be good also, because
Okay.
later on when you're working in a recent year, you almost graduate. When you're working right now, I think English become an official language, and you might have a good time for practice in writing a report
So English is
in English.
preferred.
But we accept both.
Yes. So if you have any question, you can either speak it loudly or you can send the chat. มีคำถามไหมครับ ถ้ามีคำถามจะใช้ไมโครโฟนก็ได้ หรือจะใช้แชทก็ได้นะครับอาจารย์พรพจน์ can I switch to
Sure. I stop sharing. Okay.
โอเคมีคำถามไหมครับก่อนอื่นก่อนที่จะ switch do you have any question
I would like to ask about the report in 4.1.
อาจารย์พรพจน์ there is the question about the report
Yes.
The process flow diagram with material balances per ammonia plant. So we're going to incorporate this on the report that we're going to submit, right? Or it's in the simulation file itself.
Say it again. I don't. Your sound is quite broken, so I couldn't understand. What is your question again?
The one that we need to submit, the process flow diagram with material balances. Do we need to show this on the simulation file, or do we need to show this on the report?
It's supposed to be in the report as well.
Okay.
Okay, because when you read the report, we would like to know what is your process. What is your process, right? So it will be convenient for the judge to look at their process and then come back to the result and tracking all the stream table, something like that. Okay.
Okay, thank you.
are there any other questions
They also have another question in the message. What can
Okay.
you read?
Let me check. Okay. Since the parallel reaction are provided, is there information on the conversion rate or the selectivity? Actually, if you're working with the equilibrium, I think the equilibrium will judge by itself already. So I don't think we have to specify that. The condition of the operation will provide you.
Are there any other questions ถ้ามีคำถามเชิญเข้ามาก่อนได้เลยนะครับ Therefore do not use the conversion reactor
Right,
but
right.
use the GIT minimization reactor or equilibrium reactors
Equilibrium.
and for the PSR use the kinetic reactor not the equilibrium reactors
That's right.
อย่าใช้ conversion reactor เลยนะครับใช้ equilibrium reactor หรือ GIT minimization reactor สำหรับ methanol synthesis ที่เป็น PSR ใช้ kinetic reactors โอเค Are there any questions Are there any other questions มีคำถามเพิ่มเติมไหมครับ Okay, if not, then I gonna switch to the how we do the CO2 greenhouse gas report in the AVEVA because we missed that yesterday. But if you have any question, you can come back later on. อาจารย์พรพจน์เดี๋ยวผมขอสวิตช์ไปก่อนนะครับแล้วถ้าเกิดมีคำถามเดี๋ยวกลับมาถามใหม่
โอเคครับ
โอเคครับ Okay. Yesterday we missed one part and that is how we do the greenhouse gas calculation on AVEVA. I think first we have to add the summary greenhouse gas and yesterday we see this symbol but we do not add it. So today I will add it onto the canvas. Okay, then actually we have to look at the source of emission if there is. In this process simulation, which is hydrogen production from steam methane reforming, there is one source of emission for the greenhouse gas, and that is inside the flow sheet. So we have to click onto the flow sheet. Okay, and we see full gas. So we have to add the sub-model. They talked about it yesterday, but for this one, we have to add the sub-model, and the sub-model is in economics. And we have to add the, we have to add the waste greenhouse gas sub-model. Okay, so we click on the waste greenhouse gas. Okay, that is the scope 1 emission. But for scope 2, we have to look at the steam and also the electricity used. The greenhouse gas emission is for scope 1. For scope 2, we have to look at the unit operation that require electricity and also require steam. For example, in this case, we have the compressor. So then we have to add the sub-model. And the sub-model that we are going to add is in the economics also, but it's going to be the power greenhouse gas. Okay. For the power greenhouse gas, we have to specify some value, and we can do that by go to the mini properties of the compressor. And let me close this one first. We're going to have the greenhouse gas emission data. And you're going to use the emission coefficient according to the one that is in the problem statement. For example, this one is going to be in the unit of kilogram per kilowatt hour, and the value is 0.5986 kilogram of CO2 per kilogram per kilowatt hour of electricity. Okay, we have to do it for all unit operation that involve the electricity. For example, we have two compressors. We have to add sub-model, and it's going to be economics, and it's going to be the same power GHG. And we have to go again to the mini properties, and we have to specify the same conversion emission factor into this information also, and the value is the same, and that is 0.5986. Okay, and then we have to, for this particular worksheet, process simulation, we have the flow sheet and we have the mean. Therefore, right now we are at the mean, and we have to, actually, we need to do this for the steam input, but right now there is no steam input, and so I will perform the example for the calculation. If you have the steam input, the way we're going to do it is we are going to add steam into this sink. Add sub-model into this sink. We do the right click, then go to the sub-model, then go to the add, then go to the economics, and then go to the steam GHG. Click on this one, and then you have to go to the mini property again. And for the mini property, you will have to fill in this GHG emission data. And I provide you the boiler efficiency, and I provide you that the fuel is natural gas, and therefore we have to specify that is its boiler efficiency, and we have to specify the fuel. The way we're gonna define is we're gonna click this one, and then we go to the submodel, sorry, economic submodel, and then we're gonna select natural gas EF for the fuel. Okay, and for the factor, according to the problem statement, the efficiency for the boiler is 0.82. Okay, so after that, I press enter, and I will go to the greenhouse gas summary data. And if you want, you can make the change for the unit. You can then make the change for the CO2 emission. You can make the change for the methane emission. This is the, I think, scope 1. This is the emission for the CO2. And this is scope 2. Scope 2 comes from steam. Scope 2 comes from electricity. And we can make the unit adjustment so that it's the same one. And if you want, we can put this information into our canvas. Okay, if you have any question, please let me know.มีคำถามไหมครับ Because you have to report scope 2 emission, you have to do this step. And for this CO2 scope 2 emission is this number for the process we are looking at, and it is hydrogen production from steam methane reforming. มีคำถามไหมครับ Okay, if not, then let me continue on the topic that I am preparing, and that is how you're gonna submit the report. You are going to submit the report by Google Form, and since I have limited space of Google Drive, I think I will allow you to submit only once, and it must be done before 11:59 p.m. on April 14. The review process is the blind process. Therefore, there will be no name, no university mentioned in the report. นะครับ เนื่องจากกระบวนการประเมินเป็นกระบวนการแบบมองไม่เห็นว่าใครเป็นคนทำมาใครเป็นคนรีพอร์ตใครเป็นเจ้าของรีพอร์ตเพราะฉะนั้นอย่าให้มีชื่อของนักศึกษาอย่าให้มีชื่อของมหาวิทยาลัยปรากฏอยู่ในรีพอร์ต and each team is assigned by the team index which I submit by the email at this morning. For example, in this case, I submit the email to one team, and in this team, they assign the team index, which is 750. You're gonna use this team index in your submission. And please name the file according to the system over here. So it's gonna be h750-01.pdf and h750-02.simx. I do personally suggest that you submit the library because sometimes some simulation will not work if we don't have the library. Library means when we work on the reaction, you're gonna have to create the library. And I do suggest that you can also submit the library when you submit the report, and that's why we have 01, 02. If you have the library, it's going to be 03, 04, and 05. Okay. So up on the submission of your report, each member of a team will have the certificate after the final round. And I would like to make the important point that without submitting the report, there will be no certificate of participation. Okay. And I personally would like to thank all contestants who spend the holiday working on this process simulation. And I would like to thank also Ajahn Pornpot, the committee for the TIChE AVEVA process simulation, also Department of Chemical Engineering KMITL. And I would like to thank TIChE and also AVEVA, who are the major sponsor for this content. And right now, if you have any question, Ajahn Pornpot and I will be more than happy to answer any of your questions.
Ajahn Theerasut, we have 2 more questions in the message. One from me.
I think we don't have the emission and of the greenhouse gas in the process, and that's why we don't have the scope 1. Is that
But
correct,
you-
Ajahn Pornpot?
But you just show us, how to estimate the scope 1 from the diagram.
No, sorry. No, normally scope 2 is include scope 1.
Okay, thank you. Ajahn Nalisa, normally scope 2 is include scope 1. Okay?
No, actually, like carbon footprint, they divided into 3 scope. Okay, scope 1 is inside. Okay,
That's right. But when
Right,
you
the
report
second
scope 2,
one,
you
the
got to include scope 1 as well.
right. The second one is like the electricity that you import. Okay. So I think in this one it means scope 1 and 2.
That's
Okay.
right. That's right.
That's right. Okay,
Right.
sorry. Scope 1 and scope 2. Okay.
Right.
And can you repeat when the unit has steam input again? You mean steam or steam? You mean ไอน้ำ or you mean stream of material? เพนพิชยา steam. Okay. So actually, when we do the scope 2 analysis, we have to let me delete the submodel first. In case that you make some mistake, you can delete the submodel by going to the steam and then go to submodel and then delete. For example, right now I am going to delete GHG and I am going to add the submodel again. We go to the submodel, we go to add, and then we go to the economics. And because it is steam, then we select the steam GHG. Okay. And actually, the unit that you are talking about, I believe it in this summary greenhouse gas. The way we are going to do it is we are going to go inside this summary GHG, and then you can select any unit you want. Ajahn Pornpot, should we set the unit so that the contestant report the same unit?
Sure.
So I think it will be kilogram per hour. Is that okay?
Ajahn Theerasut,
Yep.
like for carbon footprint, it usually like report as, ton of CO2 annually.
Okay. So in that case, we report KTA,
Yes.
10 kiloton per
Right.
annual. Okay. So everything should be reported in kiloton annually, and I will send to all contestants by the line and also the email. Thank you, Ajahn Nadisala. Okay, let me go out from this AVEVA so that I can see the questions มีคำถามหรือมีประเด็นไหนที่สงสัยไหมครับ
Yes. They asked about the condition of the steam reforming for ethane. Is it the same condition? Yeah, I saw that also that we did not put the condition should be the same as steam reforming for the methane.
Okay, for the Sahara, I will submit. I will contact you later on. Okay, I might make a mistake for the Sahara. Okay. สหรัฐครับเดี๋ยวผมติดต่อสหรัฐทางอีเมลนะโอเคครับมีคำถามอะไรเพิ่มเติมไหมครับ for the equilibrium reaction you have to dig into detail of your chemical thermodynamics because unlike unlike Aspen Plus you have to calculate K by yourself actually scope 2 will include the scope 1 and also steam and electricity โอเคภวัต utilities mean steam and electricity
Right, we confirm to student that right for greenhouse gas we need to include scope 1 and 2.
yes
Okay. And also the unit, okay, is kiloton annually.
Mm-hmm. มีคำถามอะไรเพิ่มเติมไหมครับ Are there any questions scope 1 is for emission directly at the source for example if you have CO2 burning inside your plant if you have CO2 emission directly from your plant
I would like to add if you have any fuel, okay, it's also scope 1.
yes
In your furnace, for example, you use natural gas.
แต่ก็คือเราก็รู้อยู่แล้วว่าใช้ไม่ได้มันก็เอฟเฟกต์กับตัวอื่นอะไรอย่างเงี้ย
Okay.
กับที่ภาษาอังกฤษกับ
Okay.
มีคำถามไหมครับคือยกตัวอย่างนะlet me explain that for example you have the combustion and you have the emission this is scope 1 the full gas and for scope 2 is the steam and electricity scope 1เนี่ยจะเป็นการปล่อย greenhouse gas โดยตรงนะครับยกตัวอย่างเช่นถ้าเกิดเราดูตามเนี้ยto turn on the microphone sorry if we go to the example right now we have the combustion and from the combustion at the exit we have the full gas and that is scope 1 For scope 2 is for the steam and for the electricity that you bought from other places, but other places need to burn something in order to get the electricity, in order to get the steam. Okay? Ajahn Nishra, would you like to add more information on that? อาจารย์พรพจน์ there is the question about OSBL supply condition. Is that for the natural gas feed?
That just only tell us it is come out from other place, not in the plant. That's all. It's outside boundary limit. Do you hear that?
Right, as Ajahn Ponpot mentioned, like inside the plant, any activity inside the plant, it's going to be combustion or non-combustion, also fugitive emission. Okay, it's scope 1. Okay, and scope 2 is like when you import electricity, steam, or like to use in your plant. Okay.
มีคำถามอะไรเพิ่มเติมไหมครับ ถ้าไม่มีคำถามผมขอถามนิดนึงนะ มีใครยังติดตั้ง AVEVA Process Simulation ไม่ได้ หรือมีปัญหาที่ AVEVA Process Simulation ทำงานได้ไม่เต็มที่บ้างไหม ถ้ามีขอให้ยกมือขึ้นนะ Raise your hand ใน Microsoft Teams นะ If you have any problem about installation of AVEVA, please raise your hand on Microsoft Teams so that I know which team do have the problem. Okay, I don't think no one raised the hand, so I think everyone can install. อาจารย์พรพจน์ there is the question about PSA. Which unit operation should we use for the PSA?
Actually, yesterday Malila already mentioned about PSA. It's just a component splitting.
Okay, so you can go back to the record training yesterday, and actually there are some complex way of modeling for PSA. However, it has to be in dynamic mode. So Malila and also Raj suggest that we use the simple component splitting.
Yeah, normally for steady state, it's just component splitting.
Ajahn Ponnput, I think all contestants would like to go and work on the process simulation right now.
I think so.
So,
yeah, I think so.
in case you have the problems later on, please contact us by using the line group. The committee will not answer to any direct communication with the contestant other than the problem on the AVEVA installation. And actually, I would like those who have the problem to report it now so that I can provide the assistance you may need. คือต่อไปนี้เราจะไม่ติดต่อโดยตรงกับผู้เข้าแข่งขันรายใดรายหนึ่งแล้วนะครับยกเว้นจะเป็นปัญหาเรื่องเกี่ยวกับการติดตั้งAVEVA Process Simulation แต่จริงๆแล้วผมก็อยากให้นักศึกษานิสิตที่มีปัญหาAVEVA Process Simulation เนี่ยรายงานตัวตอนนี้ก่อนนะเพื่อที่ผมจะได้จัดทีมเข้าไปช่วยเหลือไม่ทราบว่ามีไหมครับ Okay. Maybe so I will not disturb your time of working on the contest, and I hope that all of you get some good experience and happy process simulation, and we are looking forward to all of your report and also all of your process simulation file. อาจารย์พรพจน์ would you like to say something so that we can close this event?
Okay, I will say enjoy it. Hopefully you enjoy. Have a good time.
Okay, thank you very much. Goodbye.
บ๊ายบา
ขอบคุณ
ย
ครับอาจารย์นิสราขอบคุณทุกคน
สวัสดี
ครับ
ค่ะ
สวัสดีครับ สวัสดีครับอาจารย์เจริญสุข
สวัสดีครับ
ขอบคุณมากครับ สวัสดีครับ